Good morning, guys. Hope all are doing well. Welcome to Self Help Maths Academy. So, today we'll begin with some more examples on the linear algebra. So, here, if you see the first example of today, the consider the matrix 2a, b2, where a and b are real numbers. The two eigenvalues of the matrix are lambda 1 and lambda 2, which are real and distinct. That is, lambda 1 is not equal to lambda 2. Then we have to find out when this particular condition will be true. When A is less than 0 and B is greater than 0. B condition A is greater than 0 and B is less than 0. And C is given and D is given. So let's find what is the correct condition for this. So first we will understand the question. So they are given the matrix and A and B, they are, this is the question which is asked in 2011. Okay, so this particular question is talking about two eigenvalues of the matrix lambda 1 and lambda 2. They're real as well as distinct. Okay, so we have to find out for what value of A and B this condition holds. Okay, so let's begin with the problem. So we will start with the problem. If you take the problem here, the matrix, we know that the given matrix here is A is equal to, if I take A is equal to, say this is 2A and B 2. This is a given matrix. So when this is a given matrix, we know how to find out the eigenvalue. So the eigenvalue of this matrix will be given by the characteristic equation, determinant of A minus lambda I is equal to 0. So if I do this for this particular matrix, we will get it as 2 minus lambda A B 2 minus lambda. This is equal to what? This is equal to 0. So if you find out this quadratic equation, this is just 2 minus lambda the whole square minus AB equal to 0. And clearly, if suppose this AB, if I take 0, suppose AB if I take 0, then this equation becomes 2 minus lambda square equal to 0, where lambda will be equal to 2 and 2. So which are same eigenvalues. But as per our question, they are distinct. They are real and distinct. That means this is not allowed. This particular AB is equal to 0. That means A is equal to 0, B is equal to 0 cannot be an option. If you see the option, so here the A equal to 0, you can see the last option A equal to 0 and B equal to 0. So we can eliminate the straight away the option D because they have given that lambda 1 and lambda 2 are real as well as distinct. So when this is given, let's see then how exactly one should solve this. That is the next part of the question, right? So let's see how do we do it. Okay, so if that is the case, then we have to consider whatever the equation you have got, 2 minus lambda square minus AB. So this is the equation we have got. So if I just take the square of it, it is 4 plus lambda square minus 4 lambda minus AB. Okay, so this implies lambda square minus 4 lambda plus 4 minus AB, if I take in this way. Okay, so it is a quadratic equation, and if you remember the equation, if suppose ax square plus bx plus c, if you have an equation of the form, then your discriminant, that is capital D, if it is greater than 0, discriminant means b square minus 4ac. If it is greater than 0, then we say that the roots are real as well as distinct. So we are going to apply this particular concept here. So here if I take this, A is 1, B is minus 4 and C is 4 minus AB. So let's see what is B square minus 4AC. B square means here it is 16 minus 4 into 1 into C will be your 4 minus AB. Okay. So if you see this, the 16, here it is 16 minus into minus, it is plus AB. Okay. So this has to be greater than 0 when it has to be real and distinct. When AB is greater than 0, so AB is greater than 0 means if, like what condition we have to choose out of the given three conditions. That is the next important thing. So here we have got AB greater than 0. Okay, so let's keep this in the mind. And now we will see the options of this question. Okay, so if you see the options of the questions, so here if suppose if I take say AB greater than 0, I have got. If I take A less than 0 and B greater than 0, for example, A less than 0 means say A is equal to -1 and B is equal to 2. So what I get AB into? AB will be equal to -1 into 2, that is -2, which is less than 0. So that means first option I cannot take. So what if I take A greater than 0 and B less than 0? So if we take A is equal to say 2, B is equal to say -3, what will be your AB? It is 2 into -3, that is -6, which is again less than 0. But I am in need of greater than 0. Again, this option B also will not work. So what if A is less than 0 and B is less than 0? Take A is equal to -1 and B is equal to -2. Take AB, that is -1 into -2. So this will be 2, strictly it is greater than 0. That means option C will work. Option C will work. So therefore, this particular matrix will be having the eigenvalues which are real and distinct only when A is less than 0 and B is less than 0. Okay. So this is how you're supposed to solve this type of question. Okay. So now let's go to the next question. The next question here, if you see, this is just a solution, guys, which I have already done it. Now, if you see, the matrix A is a square matrix, which is neither symmetric nor skew symmetric. And A transpose is its transpose. The sum and difference of this matrices are defined as S is equal to A plus A transpose, and capital D, the matrix D is A minus A transpose, respectively. Okay. So then which of the following statements are true? That is the question. So they have given that both A and B are true. And then they have given that, if you see both the S and D are the symmetric, then they have given you both S and D are skew symmetric. S is symmetric, but D is not symmetric. Like that, they have given all the options, all the possible options, in fact. So you have to see the options and you have to find the correct one. Okay. So before that, you should know, in order to solve this particular example, you should know some of the property of symmetric matrices. Okay. So in very important properties, if suppose you are you know that if S is symmetric matrix, if S is a symmetric matrix, okay, in general, if S is symmetric matrix, then S can be written as matrix A plus its transpose. When it is possible, when A is a matrix you are having, then if it can be expressed as matrix A plus A transpose, then S is symmetric here. Similarly, if you can express your matrix A as matrix A minus its A transpose, let me denote it as D because in the example they have denoted as D, then here this D matrix will be skew symmetric. It is skew symmetric. Okay, skew symmetric. So this is what is important properties which we have to know. Then we have to check with one example if you want. Okay, so if you just see this particular problem here, you can check with the example. You can take any matrix. Say if I take matrix A, any square matrix you take, say 1 2 3 4 if you take, okay, a simple matrix you take, then take the transpose of it, A transpose. This will be 1 3 2 4. Okay, then if you take A plus A transpose, it's A and A transpose if you take, then this will be 1 2 3 4 plus 1 3 2 4. So here you will be getting 1 plus 1 is 2, 2 plus 3 is 5, and 3 plus 2 is 5, again 4 plus 4 is 8. You can see that the principal diagonal elements, non-diagonal elements are same, and principal diagonal elements, there are principal diagonal elements and non-diagonal elements will be having same. So if you just take the transpose of it, you will get the same matrix. That means your given matrix is symmetric. Okay. So if the given matrix is symmetric and if you're able to express it as A plus A transpose, then S is symmetric. Okay. So according to this particular property, we can say that here S is symmetric and D is skewed symmetric. Okay. So because they clearly mentioned that S can be expressed in this way and D can be expressed in this way. Okay. So clearly from this it is clear that S is symmetric matrix and D is skew symmetric matrix. Okay. Let's move on to the next example here. If you see the next example, we can check with the example. I just shown you the example. So this question appeared again in 2011. The system of equation, this is a system of equation, has no solution, for the values of lambda and mu. For which values of lambda and mu given by. So these are the four values of lambda and mu, guys. So let's find out the system of equation where it has to have no solution. So we are talking about no solution. Okay. So that means what? It has to have the inconsistent system. So these all are connected. So if you just see the problem, I'll just write it, the augmented matrix here. The augmented matrix for the system will be, if I write it, this will be, say first I'll write the system, x plus y plus z is equal to 6 here, and x plus 4y plus 6y is equal to 20, and x plus 4y plus lambda z is equal to mu. So this is the given system. So let's write the augmented matrix for the given system. What is the augmented matrix will be, guys? If I take the augmented matrix, this will be 1, 1, 1, 6, 1, 4, 6, 20, and 1, 4, lambda, mu. So this is the augmented matrix. Now we will do some row transformations here in order to reduce it. So R2 changes to R2 minus R1. Here you can see that there is a 1. So here also 1. So R2 changes to R2 minus R1 I'll do. And here this I will change. R3 changes to R3 minus R1. So if I do this, then I will get here 1, 1, 1, 6. So 1 minus 1 is 0. This is 3. This is 5. And this is 14. Similarly 0. Then 4 minus 1 is 3. Then this is lambda minus 1. This is mu minus 6. Okay. So here again clearly you can see this particular value. I just change the color. So here you can see this is 3, this is 3. We can use the R2 and we can make this element 0. Okay. So for this I will do R3 changes to R3 minus R2. Okay. So here I'll be getting 1, 1, 1, 6. This is 0, 3, 5, 14. And here it will be 0, 3 minus 3 is 0, lambda minus 1 minus 5, that is lambda minus 6 here, and this is mu minus 6 minus 14, it is mu minus 20. Okay, so here clearly, guys, now it is in the lower triangular form, or you can say the echelon form, which is very standard one. And this system because they're in the question they have told that it has to have no solution. They're talking about no solution. So when it is no solution, whenever the system is inconsistent, when it will be inconsistent, whenever you will be getting the contradiction. So that is possible only when this lambda minus 6 is equal to some this is equal to 0, and this mu minus 20, this is not equal to 0. When only this condition possible, then only we can say that this particular system is inconsistent. What if lambda minus 6 is equal to 0 happens? This implies lambda is equal to 6. When mu minus 20 is not equal to 0 means it is mu is not equal to 20. So if lambda is equal to 6, this will become 0. Okay, so this term will become 0. And if mu is not equal to 20 means it may be any number. So here we will get some number. So 0 is equal to number, like this you will get an equation, which is the contradiction. This contradiction creates the inconsistency. When it is inconsistency, that means the system has no solution. Like this, these terminologies are interconnected. The same problem you can solve by using the rank method also. So this, if suppose you are good in row reduction, so you can go with this method. Within 2 steps, you will get the answer. Okay. So the answer is lambda is equal to 6 and mu is not equal to 20. So let's see the option. So if you see the option here in this, you can see that lambda is equal to 6 and this mu is not equal to 20. So that means option B is the correct answer. Okay. So like this, you should approach to the question, guys. Now come to the next question. So here in this question, for the matrix A, 5, 3, 1, 3, one of the normalized eigenvectors. So they are asking for one of the normalized eigenvector. Okay. So let's see which is, these are the 4 options given, guys. Out of this 4 options, so one will be the eigen. They're not asking only the eigenvector. You have to be very careful. They're asking for normalized eigenvector. So we have to be very, very careful. Whatever the eigenvector you're getting, that you have to normalize further in order to get the normalized eigenvector. So let's begin with the matrix. So what is your matrix given as? It is A is equal to 5, 3 and 1, 3. So this is your matrix. And we know to find out the eigenvalues, because we have to find out the eigenvalues first in order to find out the eigenvector. So now first, we know that how to find out the eigenvalues. So we'll start with the characteristic equation. It is A minus lambda I is equal to 0. So this implies determinant of 5 minus lambda 3 and 1 3 minus lambda, which is equal to 0. So this implies it is 5 minus lambda into 3 minus lambda minus 3 is equal to 0. So this will give you, say, 5 here it is 15 minus 5 lambda minus 3 lambda plus lambda square minus 3 equal to 0. To solve it further, it is lambda square minus 8 lambda plus 12 is equal to 0. Okay, so here after multiplication I should get 12. After addition or subtraction I should get minus 8. It is minus 6 and minus 2. So that means I'll get the this fractions are lambda minus 6 and lambda minus 2 is equal to 0. So this implies lambda is equal to 2 and 6 are our eigenvalues. So now we will find out for lambda is equal to 2. For lambda is equal to 2, if I want to find out the eigenvector, so we know that it is Ax is equal to lambda x. But since my lambda is equal to 2 here, it is Ax is equal to, say, 2 into x. Okay. The augmented matrix will automatically, it is A minus 2i comma 0. Okay. So this is our augmented matrix will be. Let's see what will happen. 5 minus 2 here. Then 3, 0. This is 1, 3 minus 2, 0. Okay. So this is augmented matrix which we are taking. Now do the transformation. So this will be 3, 3, 0. This is 1, 1, 0. If you want, you can just interchange R2 and R1. This you will get it as, this is 1, 1, 0. This is 3, 3, 0. Now you can just, either you can do this or you can take 3 from R1 and then you can just do R2 and R1. Anything you can do. Just say R2 changes to R2 minus 3 times of R1. If I do this, this is 1, 1, 0. This is 0, 0, 0. This is 3 minus 3 is 0. 3 minus 3 is 0. So this is 0. So clearly, guys, if I just want to write this as a solution, I'll get it as x1 plus x2 equal to 0. Here you can see either you can write x1 is equal to minus x2 or x2 is equal to minus x1. I'll write here x2 is equal to, say, minus x1 or x1 is equal to minus x2. Anything you can write. So if you want to write this way, you can write, or you can write it as x1 equal to minus x2 and x2 is what? X2 is free variable. So if I write a solution, it is x is equal to x1, x2, where x1 is minus x2 and x2 is x2 because it is a free variable. If I take x2 in it out, it is minus 1, 1. And if I take x2 in particularly, say, minus 1, then this particular vector will become 1, minus 1. Okay, so this is my vector v. So this is the eigenvector, but I am interested in normalized eigenvector. So I have to take the norm of this first. Norm of this vector will be square root of 1 square plus minus 1 square, which is square root of 1 plus 1, that is root 2. But what is your normalization of a vector? So v cap will be equal to v upon norm of v. So this is equal to, since already you have this is your v. So norm of v is root 2. This will be just 1 by root 2 minus 1 by root 2. So just see the option, guys, which will give us this 1 by root 2 and minus 1 by root 2. If you see the option here in this question, yeah, 1 by root 2 minus 1 by root 2. So option B is the correct answer. Okay. So when you will be solving more problems more frequently, guys, and regularly, so you can solve these problems easily and within a speculated time interval. Okay. So without any mistakes. So you have to solve more and more problems. So let's see the next example. If you see, this is our system, guys, and the system of algebraic equation, and moreover this question asked in 2012 and it asked for the mechanical engineering branch. The system of algebraic equation given above has, so it has a unique solution. This is the solution. It has two solutions. It has infinitely many solutions and no feasible solution. So let's understand this particular problem again. So let me start with the solution here. We will write the system of equation what is been given here and we will try to solve it. Okay. So let's begin with the solution. So what is the system they have given? So if you see the system of this equation, so here I'll write the system of equation. It is x plus 2y plus z is equal to 4. and 2x plus y plus 2z is equal to 5, and x minus y plus z is equal to 1. So this is the given system, guys. So we have to write it as in terms of the augmented matrix. So let the augmented matrix of the system will be 1 2 1 4 2 1 2 5 and 1 minus 1 1 1. So this is the augmented system of this equation. So let's do the row transformation. Now you may solve this example by using the rank concept, and also you can use this concept which I'm going to solve it right now. Okay, so let's see. I'm going to just do the row transformation, simple row transformation. Since here it is 2, here it is 1, R2 changes to R2 minus 2 times of R1, and R3 you can see here it is 1, so R3 changes to R3 minus R1. So by doing this row transformation, here we will be getting this is 1 2 1 4, this is 0 1 minus 4, that is minus 3. Okay, this is minus 3, and 2 this you'll be getting here, it is 2 minus 2, that is again 0. Okay, then here it is 5 minus 8, that is minus 3 again. And similarly here R2 R3 minus R1, it is simple. So here you will be getting 0, minus 1 plus 2 is 1, 1 sorry minus 1 minus 2, it is minus 3, I'm sorry. So it is 1 minus 1, that is 0 here. Again 1 minus 4, it is minus 3 here. So clearly you can see R2 and R3 are similar. So we can just do this. R3 changes to R3 minus R2 I'll do. This I will get it as 1 2 1 4. This is 0 minus 3 0 minus 3 0 0 0 and 0. So clearly guys, if you know the concept of pivot position and basic variables and free variables, it's very easy and quickly you can solve the answer. Now see, in this particular question, here this is the pivot position, and in the this is the pivot position, guys. So whichever columns is having the pivot position, those are called as basic variables. Those are called as basic variables. And which column does not have the pivot position, that is called as free variable. That is called as free variable. Okay, and if you know the theorem, in any given system of equation, when you are solving it by using the echelon form or row reduced echelon form, if you come across at least one free variable, guys, then that particular system has infinitely many solution. It has infinitely many solution. If it has only basic variables, then it has unique solution. If there is no free variable, if there is only basic variables, means if each column is a pivot column, then it has a unique solution. If there is something called 0 is equal to some number, okay, 0 is equal to some number if you're getting, or any particular row you're getting in the form of 0 0 b, so this type of row you're getting in any of the like row, it may be in any of the row, then that particular system is inconsistent, or we can say that it has no solution. So please remember, these are the important points. So in this particular example, guys, you can see that this x3 is a free variable. So x3 is free variable, means we can get how many solution? Infinitely many solution. You give x3 is equal to 1, one type of solution. x3 is equal to 2, another solution. x3 is equal to minus 1, another solution. So like this, you can have infinitely many solution. Thus, this particular system has infinitely many solution. Okay, so the answer is it has infinite number of solution. Option C is the correct answer. Okay. So let's see the next example. If you want to use rank concept, you can just go with the rank of the coefficient matrix. So here if you see the same way, this is your coefficient matrix, guys. Rank of this matrix, since one complete row is 0, so rank of this matrix cannot be 3. So it has to be what then? Less than 3. Less than 3 means you take any 2 cross 2, it is 1 into minus 3 minus this is 0. That means what? It is having the rank as 2. So the coefficient matrix rank is 2 here, and rank of the augmented matrix, if you see this augmented matrix, again the complete row is 0, therefore the rank cannot be 3. Again it is less than 3, that is 2. So therefore rank of augmented matrix here also it is equal to 2. according to the property of rank of coefficient matrix. If suppose rank of coefficient matrix is equal to rank of augmented matrix, which is less than the number of variables, if that is the case, then the solution is infinite. The solution is infinite. So now you can see the rank of coefficient matrix is 2 and rank of augmented matrix is 2, but the number of variables are how many? X, Y, Z. There are 3 number of variables, so which is 3. Therefore it has infinite number of solution. Either you can solve with this method, guys, or you can solve with this method. Whichever you feel comfortable, you can go with. I'm just giving you all the methods. Okay, so just see the next example. In this example, a matrix, a 2 cross 2 matrix, which is given by A is equal to this eigenvalues of AR. So this is the question. Okay, the eigenvalues of this they are asking. So this is asked in metallurgical technology in 2012. So actually, guys, this we can solve without actually using the characteristic equation. So without using the characteristic equation, one can solve this example. So let's see how do we do it. So the given matrix is what? If you see the given matrix, it is A is equal to -3 1 and -1 -1. Okay, so this is the given matrix. Now the eigenvalues of A we want, and it's of course it's a 2 cross 2 matrix, and eigenvalues of A we want, and the option they have given as -2 -2, -3 -1, and 2 2, and they've given 3 and 1. Okay, so these are the options they have given. So we know that sum of the eigenvalues according to the property of the matrix of eigenvalue, sum of the eigenvalue will be equal to what? It is equal to the sum of principal diagonal elements. The sum of principal diagonal elements. So the sum of principal diagonal elements means what? If you want, I just write it. Sum of principal diagonal elements. Okay, so this is the property we know. So this will be equal to, you can see sum is what? -3 -1, which is equal to -4. Okay, so similarly we do have one more property related to product of eigenvalues. So product of eigenvalue is equal to what, guys? It is nothing but determinant of the given matrix. Determinant of the given matrix. Just check what is the determinant of this matrix. It is -3 1 -1 -1. So determinant of this will be minus into minus, it is +3, minus of minus, it is 1, that is 4. So here just check, guys, the sum of which particular first if you see the sum of eigenvalues, which two eigenvalues will give me -4? It is this. Here I just change the color. So this particular set and this set will give me the -4. So out of this, which I have to choose then? So for that I have gone to the next important property, that is product of eigenvalue. Product of the eigenvalue says this is equal to determinant of matrix, which is equal to 4. Now let me see which particular product will give me the value as 4. This product will not give me the value as 4. So of course this is this particular product. So therefore the option is -2. -2 is the required eigenvalue. So there is no need of finding out the characteristic equation and finding the quadratic equation, then you solving it, finding the value. Not necessary to do that. If you just remember the important properties of eigenvalues in terms of sum and product, you can solve the example easily. Okay, so this is another example, guys. Now you can see the next example. Consider the following assertion, that is A, and the reason R. And guys, this question actually asked in 2012. So what is the assertion? What is the reason? Let's see. The assertion is M is an orthogonal matrix, but not a skew symmetric matrix. And R is because M transpose is equal to M inverse and M transpose is not equal to -M, where M is given by this particular matrix. Okay, so this is the given thing. So let's see, and the option is whether A assertion is correct or the reason is correct, or both are correct, or one is correct, one is wrong. So these are the options they have given. So let's find out which one of the option is correct. Okay, so let's solve this particular problem. So in order to solve this, let me take the given matrix what they have given, and before going to solving, we know that if any matrix A is orthogonal, if it is an orthogonal matrix, if it is the orthogonal matrix, so by the orthogonal property of the matrix, we know that A into A transpose should be equal to I, or the same thing also can be written as A inverse is equal to A transpose. So both are one another same. So this is the property. Now let me take the given matrix. Here actually they given it as M. Let us take this as M. What is the matrix M? It is 1 0 0, then 0 cos theta here and minus sin theta here, and this is 0 sin theta here and it is cos theta here. Okay, so I will take the M transpose. I want M into M transpose in fact, because I have to check the condition, that is M into M transpose. So this will be equal to, here it is 1 0 0 0 cos theta minus sin theta, 0 sin theta into cos theta. This, if I take it with the transpose, it is 1 0 0 again, then 0 cos theta sin theta, then 0 minus sin theta into cos theta. Okay, so this is the transpose of M. So just if you multiply this, guys, what do you get? You just check. So this row into column you are supposed to multiply. 1 into 1 is 0, 1 1, this is 0, this is 0, just 1. So similarly this with this, so 1 into 0 is 0, 0 into anything will be 0, it is 0, guys. Okay, similarly if we just check this with this, again it is 0 here, then 0, this with this, again it is 0 here, and again if we check with this with this, it is cos into cos, cos square theta, minus sin into minus sin into sin square theta, cos square theta plus sin square theta is 1 0, you will get 0 0 1, you will get. That means you are getting the identity matrix here. So clearly you are getting M into M transpose is equal to I. That means your matrix M is orthogonal matrix by using this condition. Okay, and is it like a skew symmetric? Skew symmetric means what? A matrix A is skew symmetric if A is equal to minus A transpose. Is it happening here? Is it M is equal to minus M transpose? If you see your matrix, this is your transpose, right? Transpose of the matrix M. If you see the transpose of this, is it giving me minus M? I mean, like, this is my transpose. Is it giving you minus M? No. That means it is not a skew symmetric matrix. It is not a skew symmetric matrix. Okay. So this is not a skew symmetric matrix. Means assertion, whatever the assertion they have given, it is correct. The assertion is what? They have given that M is an orthogonal matrix, but not a skew symmetric. What about the reason? Let's see the reason now. Okay. So reason means they have said that M transpose is equal to M inverse. Of course, we have seen M transpose is equal to M inverse. That is what is true. We have seen because it is orthogonal. So M transpose will be equal to M transpose. And they have given that M transpose is not equal to minus N. Yes, because if it is not a skew symmetric. Skew symmetric means it is M transpose is equal to minus N. Since in the assertion they have given that it is not symmetric, hence it is, this particular statement is correct. So therefore both assertion as well as the reason, so both the statements are correct. So both the statements are correct means the option we will see, the option, if you see, A is right and R is right, the option B is the correct option. Okay, so like this you can solve the examples only when you will be knowing a very important and simple properties of the matrices. Okay, so like orthogonal matrix, if you know this property, it is very easy to handle. And if you have an idea about symmetric matrix, skew symmetric matrix, then these problems are very easy to handle. Okay, so now let's see the next example, guys. In this particular example, for the matrix M, this is a given matrix. Consider the following statement. So here, this is a statement. Statement P is 3 is an eigenvalue of M. Q is 410 is an eigenvector of M, and R, that is equal to 420 is an eigenvector of M. So these are the actually options that are given, P, Q, R. Out of this, which statements are correct? So these are the 4 options. P and Q are correct but not R. Q and R are correct but not P, and this C and D option. Okay, so we have to check this. So first thing is, if you see, guys, this is actually the upper triangular matrix, and in case of upper triangular or the lower triangular matrices, finding the eigenvalue is very easy. So if it is upper triangular or it is lower triangular matrix, the eigenvalues are the values on the principal diagonal elements. So here the values of the principal diagonal elements are 1, 2 and 3. That means 1 is also eigenvalue, 2 is also eigenvalue, and 3 is also eigenvalue. So clearly the first statement, 3 is an eigenvalue of M. So this is the true statement. Okay. So now we have to check between Q and R now. So in order to find out this, what we have to do? We have to find out the eigen vectors so that we can check it. So here if you see the lower or the, here you can see that for lambda is equal to 1, if we check the eigenvalue, eigenvector guys. So you know that the Ax is equal to lambda x you will use, and Ax is equal to lambda x means what? The matrix here for lambda is equal to 1 means it becomes Ax is equal to x, that is 1, 4, 5, 0, 2, 6 and 0, 0, 3. If I take this as say x1, x2, x3, this is equal to again 1 into x1, x2, x3. So this equation gives us x1 plus 4x2 plus 5x3 is equal to x1, and 2x2 plus 6x3 is equal to x2, and 3x3 is equal to x3. So guys, whatever the I mean, like, vectors they have given. So if they have given the vectors 4, 1, 0 here and say 4, 2, 0. If I take first one, x1 is equal to 4, x2 is equal to 1 and x3 is equal to 3 in one of the equation, whether it satisfies or not, we will check. So if you check this equation, if I put x1 is equal to 4, this will be 4 into, this is 4 here, x1 is equal to 4 plus 4 into x2, x2 is 1 plus 5 into x3, that is 0, is equal to x1 is what? It is 4. So this is 4 plus 4, which is equal to 4. That is 8 is equal to 4, which is not correct. Which is not correct. That means 4, 1, 0 is not eigenvector corresponding to lambda is equal to 1. Similarly, check with 4, 2, 0. If I substitute 4, 2, 0, it is 4 plus 4 into 2, okay, plus 5 into 0 again. This is equal to again 4. If you check, it is 4 plus 8, 12. 12 is equal to 4. Again, this cannot be eigenvector. So for lambda is equal to 1, these two are not the eigenvectors. Then we have to proceed further in order to check this eigenvector with respect to the remaining, for lambda is equal to 2 and lambda is equal to 3, we have to check it. Okay. So for lambda is equal to 2, if you take, what if I take lambda is equal to 2 or lambda is equal to 3? So if you just see, if I just see for lambda is equal to 2, the same equation will become here 2 into x1, x2, x3. And here guys, I just change this. This will be equal to, here. This is x1 plus 4x2 plus 5x3 is equal to 2x1 here. This is, if you just take only one equation and just substitute the value. Okay. So you just substitute this 4, 1, 0 here. This will be 4 plus 4 into 1 is again 4 plus this is 0 is equal to 2 times of 4. Yes, it is 8 equal to 8. That means this is satisfying. So this is one of the eigenvector. Similarly, if you put 4 to 0, this again will not satisfy. Just you can verify this. So 4 to 0 will not be an eigenvector corresponding to lambda equal to 2. That means again we have to continue for lambda is equal to 3. If you see for lambda is equal to 3 guys, okay, and again for second equation also it will, this particular eigenvector will satisfy. Second equation means if you take say 2x2 plus 6x3 is equal to 2x2 you are having. Say if you substitute here 2 into 4 plus 6 into 1 is equal to 2 into 4. So it is 2 4 is a 8 plus here it is 6 plus 6 into, not 6, yeah, this 6 into x3. 6 into x3 means x3 is 0. This is 0, sorry. So this will be 0 here. So this is 8 is equal to 8. Means again this 410 will be an eigenvector. Okay. So like this for any equation you take guys, this will satisfy. Okay. So therefore 410 will be an eigenvector corresponding to lambda is equal to 2. Now we have to check for lambda is equal to 3. For lambda is equal to 3 means again you just see this particular equation. If I take wherever lambda is there, if I take, what will happen? Let's see. Okay. So this particular example, if you see here, it will be 3. This is just x1 plus 4x2 plus 5x3 is equal to 3x1. If I take only this equation, I think this anyways, this is eigenvector. So we have to check only with this now. This is 4. This is 4 plus 4 into 2 here plus 5 into 0. This is equal to 3 into 4. So here it is 4 plus 8, 12 is equal to 12. Of course, for the first equation, it is satisfying. So don't decide it on with the only first equation. Let's check with the second equation. So second equation is 2x1, sorry, 2x2 plus 6x3 is equal to 2x2. So if I substitute again this equation, 2 into 2 here plus 6 into 0 is equal to 2 into x2, that is 2. So again, just check what we'll get. So here it is 2x2. Sorry, here it is 3. This is 3. 3 means it is 4 is equal to 6. Again, this is not valid. That implies 420 is not a eigenvector. 420 is not a eigenvector. Okay. So in this way, guys, you should verify the examples. Sometimes it looks like the eigenvector with the initial equation, but when you check it further, you will understand that it is not the eigenvector. So clearly, guys, if you see the question back again, so this P is the correct statement and Q is the correct statement, whereas R is not the correct statement. So for this matrix, P and Q holds and R does not hold. Therefore, the option A is the correct answer. So here, basically, guys, if you see the today's example, so here what is basically needed is a little basic concepts you need and little properties, and which are smaller one. In fact, they are not a big properties, they are smaller properties, and small properties which are having the very important role when you're solving the examples very easily and quickly in the given speculated time. And try to solve more and more problems, and when you solve more and more problems, you will become more comfortable in solving the examples. Okay, so with this, guys, we conclude today's topic of discussion. Maybe in the next class we will discuss the next questions on the linear algebra. Okay, till then, please take care. If you like the video, guys, please subscribe the channel and do share with your friends so that it will reach to many students. Thank you so much, guys. See you. Please take care and see you in the next class.